All right, so sorry that took a second, but I did have somebody ask online if we could cover some extra examples from 5.1, especially that obnoxious question 4. All right, so I got one, but it'll only be one triangle. So does someone have their values for question 4 that they want me to work with?
Yes.
Gotta grab my pen. All right, so they gave you a beta value, a B value, and a C value, right? All right, so what numbers do you have? All right, and then, okay. So we've got our three numbers. They give us a picture on the problem, but I always redraw my own. So we start with a nice big horizontal. I draw a long diagonal and then a short diagonal. So if this is the way the side lengths work, then that means I have the two triangle case. I like to draw it like this so that way if it is the two triangle case, then that's how the second side will look. All right, so our angle beta or angle B is 23 degrees. Side B is opposite that. That's our ridiculous 5.66321. And then side C, I always make that the other diagonal side. So that means angle C, which is what they call angle gamma. That's what we're going to look for, solve for first. Now, when I look at the setup though, B is smaller than C. So this suggests a two triangle setup. Now B is a lot smaller than side C. So there is a very tiny chance that there's no triangle at all. But if we start doing the calculation, I'm pretty sure what'll come out, if it's no triangle at all, we should get like a ridiculous answer or a domain violation. Like we could do the 14 times the sine of 23 to see if B is bigger than that. It probably is. So I usually just jump into my law of sines calculation. So since we're looking for angle C, I'm going to start with the sine of C, and then I have to put that over side C. And then I'm going to set that equal to the side angle pair I have. So the sine of angle B divided by side B. Now we'll fill in the numbers we know. So side C is 14. Angle B is 23. And side B is 5.66321. Now when we go to solve this, I'm going to multiply by 14. So now I have the sine of C by itself equals, leave some space, 14 sine 23 over the annoying number. And now to get rid of sine, to undo that, I'm going to use my inverse sign. So when I go to type this calculation in, I'll have inverse sine open 14 times the sine of 23, and then there'll be parentheses around the 23, then divided by the 5.66321, and then a close parenthesis. So that's what we're going to type in now. So inverse sine 14 times sine of 23, close the little parenthesis, divided by 5.66321, close the big parenthesis. So I got 74.9998. So that is essentially 75. And the problem actually runs the calculation with 75. So we want to use 75 as our angle C result here. But we got a real number, so that means we've got a real triangle. B is smaller than C, so we've got a 2 triangle setup. So I like to finish the outer triangle first. So I've got angle C. Now I'm going to get angle A. Since I know B and C, angle A is 180 minus B and minus C. B was 23, C is 75. So we get 82. Yeah. So angle A in the bigger triangle is 82 degrees. Now we need to find side A. So we'll have A on top and then the sine of angle A on the bottom. And then here we can use B, and side B has all those decimals, or since we found angle C and that's a whole number and side C is a whole number, we can also use the C values here. Either one will work. Oops. But you have to make sure you write the fractions in the same order. I put the side on top, so I couldn't write sine C on top. I had to write side C on top, divided by the sine of angle C on the bottom. So side C was 14. Angle C was 75 there. And then angle A was 82. So I'm going to multiply by the sine of 82. Then we're going to put the parentheses I'll see in my calculation. So 14 times the sine of 82, close, divided by the sine of 75, close. And it's not much bigger, 14.35281, blah, blah, blah. But angle A, 82 degrees, is a little bit bigger than 75. So side A, 14.35, is a little bit bigger than side C, 14. So that tracks with our biggest angle, biggest side, like gut check. So this is what we'd put for the answers for the first triangle. Now, the question is buggy. So it might be when you type these answers for the first triangle, it's like, I hate your answers. If that's the case, type them in the second triangle, like in the same order. So you know, angle alpha would be 82. So you'd make that alpha prime 82. Gamma prime would then be 75. And A prime would be the 14.3528. And then it should accept it as the second triangle. Now, to find the real second triangle, well, what I would label as the prime triangle, the inner wonky triangle. Remember in our diagram, like I put in that dashed line there. So that line there is still side B. So this angle here is also equal to the 75 degrees we calculated for original angle C. So that means our new C prime or gamma prime angle is going to be 180 minus C. So that's our first calculation for the prime triangle. C prime is 180 minus C. So that is always true when we're dealing with a secondary triangle. Or gamma prime, like whatever angle we first found, the prime angle is always 180 minus that. So that gives us 105 for our C prime. Now we're just going to follow the same steps we did before after we found angle C. So angle A prime is going to be 180 minus B minus C prime. So B is still 23, but C prime is now 105. So we get 52 degrees. And now we're going to run the same calculation we did before. So I don't know A, but I know the sine of angle A is the sine of 52. And this equals side C is still 14, but we'll have divided by the sine of 105 now. And then we multiply by the sine of 52. And there's what we're going to type in for our calculation. So 14 sine 52 close divided by sine 105 close. 11.421322 blah blah. I always forget the prime markers. All right, so did the answers work?
Yes.
Okay.
So even I got the first two ones, but then the last decimal numbers, I can't snap on those ones. So that figured out. Thank you.
Was it because you were typing in 74.9998? Or did you round it to 75?
I did find the integer at first. I got that.
Okay.
And when I continued to get the last side A, I don't know if I kept getting the wrong decimals or was doing the multiply by, I think I was also multiplying by inverse sign when I didn't need to be doing that.
Oh, yeah, no. Yeah, the second one is just regular sign. The easiest calculation mistake to make is to forget to close the parenthesis on the 82. So if you type it in like without the close, you'll still get a number. Sine 82 divided by sine 75. Yeah, like this way I got 13.9444. So it seems reasonable. That seems like a side length. It's not a negative number. But if we look at that angle A was 82, it's bigger than 75. Like we shouldn't be getting a number smaller than 14. It should be bigger than 14 because the side opposite it is bigger. But yeah, that's That happens, but you were getting the angles correct, so you're doing the process right. Is just crunching on the calculator. Now, some of y'all may actually get a triangle that's only going to be one wonky big triangle, because that's what I'm getting for some of my values. Let me run that calculation real quick, because I just want to see if it'll work in the top triangle or the bottom triangle. So that'd be 9 sine 67 divided by 9.99297. So I'm getting 56. Seriously. Even when you only get one triangle, you end up typing it in the bottom one, like the whole programming got messed up. Ugh. All right, what other questions from 5.1 did you want to look at? Sure. All right, so question 7 here. I've got it, mine came up with 73 miles apart, but the angles in the diagram should be the same for everybody. The only number that should be changing is that distance. All right, so first thing I'm going to do is I'm going to draw the triangle so where the angles are is a little more obvious. So I'm going to make the angles more extreme. So there's A and B, so I guess that makes our satellite C. So I've got 83.9 degrees here. And then my 86.2 is not actually angle B in the triangle. It's actually the outer supplementary angle to B. So B is going to be 180 minus 86.2, which is 93.8. And then up top, that means angle C is going to be 180 minus 93.8 minus 83.9. So angle C is 2.3 degrees. It is very, very tiny. So we've got all the angles. And then the distance they told us, it's 73 miles between points A and B. So between points A and B, that is side C. So side C is 73 miles. Now, what the heck was the question asking? How far is the satellite from station A? And then how high is the satellite above the ground? So the distance to station A to the satellite, that is the side opposite angle B. So we are looking for side B. So our first calculation is going to start with B over the sine of angle B equals, and then I know the C's, so that's what I have to use for my second ratio. C over sine of C. All right, so B, little b is what I'm looking for, over the sine of 93.8 equals C is 73 and the sine of 2.3. Multiply by that sine of 93.8. So now we can calculate our B. And again, y'all's calculation, like the only difference should be that 73 is whatever number they gave you. So I've got 73 times the sine of 93.8. Close the parenthesis, then divided by the sine of 2.3. And I get a very ridiculous number. So 1,815 miles. So that is how far the satellite is from radar station A. So I'm pretty sure in an astrophysics sense, this number is ridiculous. Like, I don't think satellites sit that far from Earth and then also still orbit Earth. I think that far out, they are not close enough anymore. But in math land, the Earth is flat and all the satellites orbit flat Earth at whatever height they're at. Because mathematicians are not good at thinking about how numbers work in reality. So they did say round to the nearest whole mile. So we are going to type in 1815 for the first blank. Now they want us to calculate the distance above the ground. So the satellite's distance above the ground, I'm going to sketch that into the figure. But distance is always the shortest distance, which is always a straight line that'll hit the ground at a 90-degree angle. So that means there is an outer right triangle here. I'm going to draw that separate. And I'm focusing on the big one because we found this long side between A and C. And then I know this angle here is 83.9. And I'm looking for how high is the satellite above the ground. I'm going to call that D. Just because if I call it H, then it looks like hypotenuse and my brain kind of short circuits. So D it is. So this is a right triangle. Right triangle trigonometry comes into play. So the sine of any angle is the length of the opposite side divided by the length of the hypotenuse. So our angle is 83.9. Our opposite side is the length D that we're solving for. And the hypotenuse is that ridiculous 1815, blah, blah, blah. So to get D by itself, we multiply by the ridiculous number. Which ridiculous number is still in my calculator. So I'm just going to put times the sine of 83.9. And I get 1,804.73 0.08, whatever, blah, blah, blah. So nearest mile for me would be 1805. Now, if you use 1815 instead of 1815 point blah, 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 your answer might be off by like 1 mile. So if it doesn't take your rounded answer, like try unrounding the answer and type that in and see if it takes that instead. Because the error margin here, like it doesn't account for this ones place very well. Yeah, I had somebody in my class yesterday whose answer was like he rounded it and it counted the rounding answer wrong. Like even though that was correct. Yeah. Did that help fix it? All right, and then problem 8. So we've got a pilot flying straight over a highway, and he knows these two signs are 4.3 kilometers apart. And at a snapshot moment, he measures the two angles of depression to look at the two signs as 32 degrees and 56 degrees. And then they ask us to find the distance from the plane to sign A. All right. So that's what we're looking for. So I can see in there is a wonky triangle. But like right now, I don't know any of the angles in this wonky triangle. So what's one angle I can figure out based on the way the diagram looks? So I can call my plane C. So could I figure out angle C? Like, what does it look like angle C should be based on those two things we have there? So 56 is measuring from the horizontal line all the way down to here. But C is measuring from one diagonal line to the other. And we know 32 is measuring from the horizontal to the first diagonal line. 56 is from the horizontal to the second diagonal line. So the two diagonal lines should be the difference between 56 and 32. Like 32 is one part, angle C is the other part, and those two parts together are 56. So part, whole. So angle C, one way to see it is 56 minus 32, which is 24 degrees. So we've got angle C. Now to see these other two angles, it's a little bit weirder. This is the whole parallel lines cut by a transversal. Or I look for my wonky Z or N shape or backward Z. All right, so you see our backward Z there? And then the angles inside the Z, as long as the top and the bottom of the Z are parallel lines, those two angles being highlighted are equal. They're called opposite interior angles. Not that the name is important, but that upper little angle was 32. So this bottom angle down here is 32. And now I know one angle in my triangle is 24, the other angle is 32. So I can calculate angle A. A is 180 minus 24 minus 32, which is 124? No. Yes? Yeah. Now it turns out we actually don't need angle A to solve this triangle. I have angle C and the side opposite angle C. I want to know the side opposite angle B, and I have angle B. So that was actually all I needed. But we could calculate angle A, and it turns out angle A is also part of a weird, different Z. So angle A is 180 minus 56, which is 124. But finishing our actual distance to sine A, side B, then we have to divide by the sine of angle B, and we have to equal this to the C's. C over sine C. Now we fill in the pieces we know. I don't know side B, but I know angle B is 32. Side C is the 4.3 kilometers they told me. And sine of angle C is 24. And then we multiply by the sine of 32. So 4.3 sine 32 close divided by sine 24 close. 5.60228. But they said round to the nearest kilometer. So we're going to type in 6. It took 6. It also took 5.6. So yes, a wonderful example of mathematicians do not understand significant figures at all. The sig fig answer would be 5.6. If you measured 4.3 kilometers, then you can say 5.6 to the same degree of accuracy. So a little bit of a geometry review there. And we don't put a law of sines word problem on the test. It's a law of cosines word problem. Um, law of cosines is actually like, it can be a little bit longer calculations because the formula is longer, but it's like plug in numbers, solve. So I find it to be more straightforward than it doesn't have a weird ambiguous case situation. Like that's really what makes law of sines like frustrating is dealing with that ambiguous case. Otherwise, the formula itself, like, you know, works nicely. Plug in numbers, solve formula, answer. So what other questions do you guys have from 5.1 or even from 4.5 or the writing assignment? All right, then let's go look at the last few slides in the amplify activity for the law of cosines. Let's see that formula in action. So that takes us all the way to slide 16. So let me flip the share. So the formula for law of cosines, this is what we use when we know all three sides, or we know two sides and the angle in between the sides. So that's a side angle side, which is different from angle side side. So law of cosines can be used for an ass triangle, but it gets like even uglier than the calculations we were doing with law of sines because you end up with a quadratic with ugly decimals. It works, it's just more ugly work. So there's three different formulas here. On the test, I just give you the third version of the formula. But notice the pattern in the formulas. So the third one starts like the Pythagorean theorem, but like reversed. So our Pythagorean theorem is normally a squared plus b squared equals c squared. This one, we put the c squared first equals a squared plus b squared. And then we have this extra wonky term, minus 2ab cosine c. So the two sides being multiplied are the same two sides that were being squared and added. And then cosine of the angle that matches the side that started it out. So c squared on the outside, then it's going to be angle C. If it's b squared on the outside on the left, it's going to be angle B. A squared, it's going to be angle A. So the formulas are just the letters like traded out and substituted. So it's really just the same formula three different ways, but it's the same formula. So on the test, I just give you one of them. And then on this question on the test, I give you a triangle with numbers on it, but I don't label any of the sides in the triangle. So that way you can fill in the labels so they match the formula and it works. But first, let's just practice using the formula. Let's see it in action. Oops, wrong thing. All right, so given a triangle with sides 10 and 12, and the angle between them is 30 degrees. So I see my 10 and my 12, and the angle in between is 30 degrees. So they decided to call the sides A and C and the angle B. Okay, sure. But we also could have called the angle C and the other two sides A and B, and then use the third formula. So like the labels here don't matter, just as long as you see that all three of them are different letters. So I can't use law of sines here because I don't know side B to go with angle B, and I don't have a way to figure out the other two angles to go with the other two sides. So that's why we have to use law of cosines here. Now, since they already labeled it with beta, I'm going to copy down the second formula, the b squared equals a squared plus c squared minus 2ac cosine b. So now we're going to fill in the numbers they gave us. So b squared is 10 squared plus 12 squared minus 2 times 10 times 12 times the cosine of 30. Now, this next part is where some people will make a mistake. And the mistake comes from typing in the calculator. So when I have b squared equals, everything on the right here is all buttons I can type on the calculator, correct? So I should type all of that at once. Now, some people get nervous typing everything at once, so they like to break it down. That's fine. So I'm going to do that to show you guys like what happens. So 10 squared is 100. 12 squared is 144. And then 2 times 10 times 12. It's 120, so 240. And then what I get next is, let me fix my handwriting. For some reason, people will type 100 plus 144 minus 240, and then they'll hit enter. And then they'll multiply that result by the cosine of 30. And the problem is that the cosine of 30 is not multiplying to all three of those numbers. It's only attached to the minus 240. So I can do each of those pieces, but here, if I type minus 240, I have to type times the cosine of 30 right after it. I can't break that into two separate calculations. So that's why I just say, we'll just take the line before it and just type that whole thing in. So 10 squared plus 12 squared minus 2 times 10 times 12 times the cosine of 30. So we type all that in, and we have b squared is 36.1539, blah, blah, blah. All right, so does the third side being 36 sound reasonable? Why not? Yeah, so 36 is way too big. 10 and 12 cannot bridge a 36 measure gap. But the formula was b squared equals 36. That's the other calculation mistake some people will make is they'll forget to square root. And the square root of this is 6.0128, so 6 and some change. So we're going to round that to 6.013. All right, now they want to know angle A. So now that I know side B, now I can use law of sines to solve the rest of it. We could use law of cosines. The cosine calculation to find an angle is just a little bit bigger than the law of sines calculation, but both will work. So if we're looking for angle A, I'll have the sine of A over side A equals, and now I have to use the B's. So the sine of B over B. So side A was 10. And then angle B was 30. And side B was the 6.013. So I'll multiply by 10, and then I'll have to do inverse sine of that result. So this is where it's going to look messy because I'm at the bottom of the screen. So A is inverse sine of 10 sine 30 over the 6.013. Sine inverse 10 regular sine 30 divided by that number. So 56.259. They said round to one decimal place, so 56.3. And then they want to know the third angle. So the third angle, we know two of the angles. So the third angle is just subtract from 180. So angle C is going to be 180 minus A and minus B. So we'll use the 56.3. That is the ugliest 5 ever. And minus the 30. And we get 93.7. So questions on how we used the formula, how we finished the problem. All right, am I good to make my doodles disappear? All right. Now our next one, we're given 3 sides, A, B, and C, and we're asked to find all 3 angles. So law of sines would require me to have an angle and side pair. Again, I know none of the angles, so I cannot use law of sines. So I am stuck using law of cosines. Now the hint here is a really good hint. Solve for the largest angle first using law of cosines. So, like we just saw, when we solved for an angle using law of sines, we used inverse sine as our calculation. Inverse sine, the biggest number it can spit out is 90 degrees. Cosine, though, when we use the law of cosines and get inverse cosine can actually spit out numbers bigger than 90 degrees. So law of cosines isn't going to have the restriction that inverse sine has for us. So Law of cosines, we want to use it to solve for the biggest angle. So which of our angles is going to be biggest? C. Why? Yep, it's the biggest length side. So I want to solve for angle C. So I go and use my angle C, that third form that I prefer. So C squared is A squared plus B squared minus 2AB cosine C. So take a minute or two, plug in the numbers, and start trying to get cosine C by itself. Run through that calculation, see how you do. And then I'll show you what I do so you can like double check. Because there's a couple of like mistakes that you might make, and it's better to like make it and then figure out what the mistake is. You learn better that way. All right, everybody had a chance to get to angle C? Poof. So I plugged in the numbers. I ended up with 36 equals 16 plus 9 minus 24 cosine C. So I minus the 16 and minus the 9 over. You could add the 16 and 9 first to get 25, and then minus the 25 over. You'll get the same result of 11. But the big thing is sometimes here it's really tempting, like the 25 minus 24, to just be like, oh, that's 1, so it's cosine C. That 25 does not combine with that 24 because that 24 is being multiplied to cosine C. So they're not like terms. So we have to do it this way. We divide by the negative 24. And then to get C by itself, we undo cosine using the inverse function, inverse cosine of negative 11/24. And that because what we're taking the inverse cosine of is negative, that's the sign that's showing us that we're going to get a number bigger than 90. So we get 117 and we round that to 0.3. And now we just got to find the other angles. So if that calculation felt comfy to you, you can just use the other versions of the law of cosines to find the other angles. I just personally find the law of sines calculation to be a little bit less. So if I'm looking for sine of angle A over side A equals, I got to use C's because that's the only angle I have. Sine of angle C over side C. So we multiply by the 4 on both sides. And then we have sine A equals 4 sine 117.3, all divided by 6. So we apply inverse sine to both sides. And now that's what I'll type in. So inverse sine of, inverse sine of 4 times the sine of 117.3, close the little parenthesis, divided by 6, close the big parenthesis. So I end up with A is 36.32. So we'll type in 36.3. And then last angle, of course, we just subtract from 180. So 180 minus 117.3, no, 0.3 minus 36.3, 26.4. So there is a question in the writing assignment that might literally be with these numbers where it asks you for the angles. The questions on how this one played out, how we used the law of cosines, and then how we finished it. All right, am I good to clear my scribbles?
The next two numbers being multiplied by.
Say it again.
When you're rearranging that equation, you need to keep the 24 next to the cosine of C, because it's gonna be multiplied in the end, or it's gonna be.
Yeah, because it's being multiplied to the cosine C. So I can't combine it with the 16 and 9 because the 16 and 9 don't have a cosine C attached to them. So it'd be like, it's like trying to add 16 plus 9 minus 24x. Like I can add the 16 and 9, but that 25 that they become minus 24x, the 25 doesn't have an x, so that's why they don't combine. But for some reason, when it's the numbers with cosine C, like people get more tempted to combine right there. But yeah, because the 24 is attached to the cosine C, it's being multiplied. So we have to use division to get rid of it. And we want to use division when everything else is on the other side. All right. Now the next two are just weird little word problems. And I say weird because like the diagram here has all the information we need. Reading the words is like ick. So a golfer hits an errant tee shot that lands in the rough. So there's a marker in the center of the fairway, and the marker is known to be 110 yards from the green, from the flag. While standing on the marker, he turns from the flag, he turns 100 degrees and sees his ball off to the right. And then he paces off and measures that it's 35 yards to the ball. So how far is the ball from the center of the green? So it wants to know what's the distance from the ball to the flag, to the hole. So this is a very impressive golfer for knowing that he turned 100 degrees and then was able to measure 35 yards. But with all the numbers on the diagram, we're figuring out the distance from the ball to the flag. So I know two sides and the angle in between. So that's a side angle side. So we are going to use law of cosines. So the law of cosines formula I'm going to give you guys on the test is this one. C squared equals A squared plus B squared minus 2AB cosine C. So we write that down. And now looking at the diagram, we have to figure out where do my labels go. So I've got all my side lengths, but I've only got one angle in my formula. So that angle in the formula, C, has to be the angle I'm told. So this 100 degrees here has to be C. That means the side I'm looking for is side C. So that means my 110 and my 35 are A and B. Now it doesn't matter which one we call A and which one we call B. So I'm going to call 35A and I'll call the 110B. But now that they're all labeled, now I can fill them into their positions and use the formula to solve. So C is our unknown, so we still have the C squared. Now it's 35 squared plus 110 squared minus 2 times 35 times 110 times the cosine of 100. So that's going to be a stupidly big number. $14,662.0909. Yet a ridiculous number. Way too ridiculous to be the answer. And yep, C squared. So we got a square root, which is the same as raising something to the 0.5 power. So that's just a different way to type square root on the calculator. And the square root of this is 121.087. And that seems more reasonable. 121 yards, that's opposite the biggest angle, but that's not too big. Round to one decimal place, so 121.1. And we get happy golfers. So this is closer to what the test question looks like. I'm going to give you a paragraph describing some lengths and an angle. And then I'm also going to draw the figure with the numbers in the figure. I'm going to ask you questions about that figure then. So you're going to have to use law of cosines to determine the third side. And then there's like one follow-up question. All right, so let's clear the doodles. So our last one, Harrison's building a wooden swing set for his children. Each supporting end of the swing set is to be an A-frame constructed with two 12-foot long 4x4s joined at a 45-degree angle. Now, to prevent the swing set from tipping over, Harrison wants to secure the base of the A-frame to concrete footings. So he needs to know how far apart should the concrete footings be. So I know two sides and the angle in between. I can find the third side. Now, C here, is that going to be bigger than 45 or smaller than that? Sorry. C is a side. Is C going to be bigger than 12 or smaller than 12? So it's tempting, like the figure looks like an equilateral triangle. So the drawing here looks like a 60 degree triangle. But the 45 is actually smaller than that. So instead of it being a perfect equilateral, it's actually a little bit narrower because that angle at the top is less than 60. So that means our side at the bottom is going to be less than 12. But just based on the picture, yeah, it does look like 12. So 12 squared plus 12 squared minus 2 times 12 times 12 times cosine 45. $84.353. Way too big, but then we square root. 9.1844. So 9.18. And then we get this meme at the end that is a typo left over from summer. So in summer classes, they go to class 4 days a week. Classes are extra long. So their schedule is very compressed. Our exam isn't for 2 weeks, not 2 days. All right, so let me do a screenshot of this real quick, and then I can show the screenshot for the previous one. Oh, or I can just go back one. Yeah, here. So that's the calculation I got. That is a very easy mistake to make as well. When you're typing in so many numbers, it's really easy to make one typo and then the whole thing is off. Now, if that happens on the test, I will look at your work and see if you wrote it down correctly. And then if the number is off, I'll like circle it and I'll try to crunch it. And I'm like, well, this was right. So I don't know why this was wrong. And I'll still like give you all the points or almost all the points. Like I don't like taking off points for fumbles. Let me stop the recording.